Hello everyone. Now in this tutorial you are going to learn how to draw the projections of a cone when its axis is inclined to VP. In the previous tutorial you learned how to draw the projections of a cone when its axis is inclined to HP. Now we are going to learn when its axis is inclined to VP. Okay, see here on the question you can see that draw the projections of a cone of dia 60 mm and a height 90 mm is resting on a point of its base on VP and its axis is inclined at 40 degrees to VP. The difference between the previous tutorial and this one is now the base of the cone is resting on VP on a point and its axis is inclined at 40 degrees, not the 35 degrees. Now the angle is 40 degrees. Let us see. When the cone is resting on its base on VP, the front view, when the observer views from this side, the front view appears as a circle, top view appears as a triangle. The same you can see in the projections. The front view appears as a circle, the top view appears as a triangle, and now the same I am going to draw in the AutoCAD. Okay, take the circle, radius 30. Now I am going to activate the P type first. P type, cross mark, point size 3. Okay, as I said, we need to divide the circle into 8 divisions to get the smoother curve in the second stage. Number of divisions 8. Yes, we got it. Now we'll give the notations. Let us take 6 0 A B C D E F G and H. Okay, now we completed the top view. Let us draw the projectors. Sorry, we completed the front view. Now we are drawing the projectors to draw the top view. And this is the apex point O dash, because it's a front view, right? O dash. Okay, so I am drawing the axis through this point. From the reference line, axis is 90. Now connect all the generators to the apex point. Okay, yes, so we completed the generators and the apex point. It's time to draw the base. Yes, so this is the base. Perfect. Let us give the notations. Sorry, we need to give the notation because the front view A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash. Okay, yeah, we completed the front view. Now we'll give the notations for the top view. A, this one B comma H, and this one C comma G, D comma F, and this is E. As I said in the previous tutorial, this is a circular base and all these are the generators. So these all points are of imaginary points, generator points. So this is are not at all edges or corners. So there is no point of visible and invisible lines. So that's why I'm not keeping any brackets here. Okay, now let us highlight this one, the front view and the top view. Giving the color, and I'm giving 0.35. Okay, we finished the first stage. Now when this cone is resting on a point on VP with its base, how it looks like. You can see that now. See, the same cone is resting with a point on VP, the base point A. The remaining everything is like this. It is inclined, the axis of the cone is inclined at an angle pi to the VP. So now when you see from the top, this one, when you see this cone from the top, it looks like the same triangle with some inclination. Just this triangle will get inclined. There will be no change in the dimensions. When you see from the top, you can see the same triangle. So that's why what I am going to do is that apex point O. Okay, so now I selected the notations. Yeah, Control C, Control V. Okay, you know that the axis is 90 degrees with respect to VP. You can see 90 degrees, but in the question they asked us to draw 40 degrees to VP. Now I am taking this as a resting corner A. This cone is resting on a point, not a corner, resting on a point A. So, and also I need to make the axis is inclined at 40 degrees to VP. So to do that one, I am selecting, sorry, it got selected, this one. Okay, I'm removing it. Okay, rotate this one. So I need to move like this. So that's why I am giving minus 50 because I need 40 degrees. Right now the axis is 90 degrees to VP. To get the 40 degrees, I am giving minus 50. Yes, it tilted. Now you can check dimension, angular. Perfect. The axis is inclined at 40 degrees to VP. But in the question they asked us that this cylinder is resting on a point on VP. So that's why I'm just moving this one. Okay, perfect. Now it's perfect. Yeah. So to draw the front view, when the axis of the cone is inclined to VP, to draw the front view, we know the concept of vertical projectors, and then horizontal projectors. Okay, now to mark all these points, I am taking the mtext command just a small box A1 dash. So select the 1 and I'm making it as suffix. Okay, now using this one I'm copying, switch off the ortho, base point, I'm marking each and every point. Okay, this one, intersection of the points. Okay, and also this point I'll make it as okay. Now you know that the common points, see, this projector belongs to the C dash, whereas here it belongs to C comma G. So the common one is C, so that's why this belongs to C, C1 dash. Here this one belongs to BD, this horizontal projector belongs to BD, whereas this projector belongs to B comma H, so the common one is B. Likewise you can rename everything, so this one becomes D, E, F, G, H, and this is the apex point O. Yeah, now we marked all the points. Now it's time to find out which part is visible and which part is invisible. Okay, see, when you see from the front off is visible. From G, B and D, the front off is visible and back off of the base is invisible. Here if you see in the projections, the axis, which is this, the below the axis part is very visible to your eyesight, so that's why below the axis is visible to our eyesight. G, B, D, that's what, G, B, D. And here above the axis is invisible. A, G, D, G, A, D, the back one. This is completely contrast to the previous tutorial. In the previous tutorial, above the axis is visible, below the axis part is invisible. But in this case, if you see, below the axis is completely visible and above the axis part is invisible. Simply we can say that the divisions which are nearer to the reference line are invisible. So basically we need the basic understanding than these points. We need to think which points are visible, which points are invisible. Okay, so we know that this is the axis. Okay, let me load line, load. I'll take center 2 for axis lines, load, dash 2 for invisible lines. Okay, okay, as all we know that this is the axis lines. I am giving the center 2. Yeah, this is the axis line. In the previous tutorial also I took the same, okay, axis line. As I said, these are the generators which are should be thin, not the thick, so that's why I reduced it. Okay, finished. And now, as I said, below the axis, which is very near to your eyesight, so this part is visible. C, G, D, F, E, C, D, E, F, G. So take the spline command from here, 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 then here. Press the space bar to this one. Next again a spline, because off of the base, see this one. Press the space bar to exit. Yeah, okay. Now let us give some color and line thickness. later we can give the okay. So this part is visible and this part is invisible. Above the axis part is this one, so I am taking it as dashed line. See, very clearly visible. Okay, now we finish the base. Now we need to give the apex points. So take the line and connect the apex point to the extreme point of the cone. See, one more, this one too, this one. Okay, so when you see from the front, this is clearly visible, so that's why I'm giving the continuous line 0.35. Perfect. Okay, we completed the apex point as well as the base also. One more thing, in the previous tutorial I missed to say that suppose if you want to see here in the layout, paper, zoom window, see that here the line, axis line is not so clearly visible, but in the model space it's clearly visible, so there exists a difference. So that's why you can take a command LTS, line type scale. Right now line type scale factor is 1. I am changing it to 0.5. See here, immediately the scale changes, whereas in the, you can see here now it appears. Now the line type scale, changing it to 0.5, you can see very clearly the axis, whereas in the when it is 1 it doesn't shows, whereas when I change it to 0.5 it shows. So based on the system, each and every computer, each and every person, it will vary, so no need to follow the same values. You can change line type scale. Suppose previously 0.5 is right, now I am changing it to 0.4. See, again it changes. So based on your adjustability you can change the scale. So the maximum value is 1, the minimum value is 0. You can keep any value in between 0 and 1. Don't go beyond 1. Okay, we finished this one. In the previous tutorial, again I missed one point, is that representation of axis in the this view. In the previous tutorial in the top view I missed it. Now see, I want to give the axis from O1 dash to center of this one. So take a line from here to here, because it is not overlapping with any lines, so clearly we can mention the axis 0.35 and I am taking center to line for axis. Whereas it is overlapping with the projector, see this is the axis line and this is the projector, so that's why I am just moving it here and then placing it here. Now clearly you can see in the layout, you can see clearly, you can see the axis. In the previous tutorial I missed it. The same follow, the same method you can apply for the previous example also. Okay, the unwanted portion I am deleting it. Okay, now give the dimensions DAL for the cone height 90, you can see. Okay, DDI, dimension of diameter. Yeah, perfectly. In this case, presently I took the resting corner as A, the resting corner as A. Suppose if you are taking the resting corner as E, how it will change. In the previous tutorial also I explained two methods. Now I am going to do this one. Just I am copy, just pasting it here instead of drawing this one again. Now I am deleting everything here. This one I don't require. Okay. Switch on the auto. Okay. This is just to show the difference between when the axis is inclined to this side or that side. That's it. Okay, the same. Now again I am drawing the, first we need to okay, Control C, Control V, I pasted it here. Now rotate. The axis is inclined at 40 degrees to VP. Previously I gave -50. Now I am going to give just 50. Yeah, see, it moves into anti-clockwise direction. Again I am selecting, because this corner should be on reference line. Okay, now it's perfect. In the previous case it is resting on point A. Now it is resting on point E. So now you can give the axis reference inclination, yes, 40 degrees, perfect. So to draw the final front view, draw the vertical projectors. Okay. And draw the horizontal projectors. This one up. Right now I am trimming the bush. Okay. Now let us give the marking points. This one, okay. Let us change this. This one is the C1 dash. This one is the B1 dash, A1 dash, H1. This is G1 dash. This is F1 dash, E1 dash. This is D1 dash. Yeah. Now we marked all the points. If you observe carefully, as just I explained in the as I just explained here, in this case, below the axis is clearly visible, above the axis is invisible. The same you can see here. Below the axis part is A, you can see GCA, CAG is the visible part. Above the axis is invisible. So take the spline command from here. Okay, again take from here, press the space bar to exit from the command. Okay, finished. Let us give the color, line weight. As I said, this half of the base is visible and this is invisible, that's why I am giving the dasher line. You can see very short dashes. Okay, now it's time to give the apex point. Perfect. Perfect. So this apex points in the O1 dash. Perfect. Let us give some line weightage. The final step is that we mark the base as well as the apex point, and the final one is the axis. So from here to here, axis should be located. I'm just line. Okay, take this one, your color 35, and this is a center to axis line. Perfect. So with this we completed the projection of a cone when it is inclined to VP. So you can see that either you can draw in this axis is inclined here this side, or axis inclined to this side. Let us give the dimension for this one. See, 90. Perfect. You can check it out in the layout. Perfectly it fits. And this is all about how to draw the projections of a cone when it is inclined to VP.